So today we are going to start chapter 11. Now, part of chapter 11 you've probably already seen before in a pre-algebra course. You're going to be calculating circumference, area, surface area, volume, which is probably some things that you've seen before. There will be some things that maybe you haven't seen before, but we will cover all of those as we go through each section. Now, chapter 11 is a bit long. I will break it up into two different parts, just like I did for chapter 10. So today we're going to talk about circumference and arc length. So the first thing we're going to do is define what circumference means and see the two formulas that you can use to calculate circumference. So the circumference of a circle is just the distance around the circle. So in this picture, it would be for us to measure all of this, the distance all the way around the outside of the circle. It's sort of like perimeter. However, they don't refer to the distance around the outside of the circle as perimeter. They call it circumference. And there's two formulas you can memorize. You can either memorize it as pi times the diameter, or if they give you a radius, 2 times pi times the radius. Because in order to turn a radius into a diameter, you just double it, times it by 2. Now, keep in mind that multiplication is commutative. And what I mean by that is this formula of pi times the diameter. You can also memorize it as diameter times pi. Because remember, it doesn't matter the order you multiply two numbers. For example, if I do 2 times 3, I get 6. But if I flip it around and say multiply 3 times 2, it still gives me the same answer. And that's the commutative property. So technically, you could memorize the formula as either pi times the diameter or diameter times pi. Same thing for the radius. When you do 2 times pi times radius, or if you had to do something without a calculator, you could times the radius by 2 and then by pi. Now, in the beginning questions of the homework tonight, they're going to tell you when you're calculating this circumference to use your calculator. So unless the question specifies, leave it in terms of pi, then you're using your calculator and you're using the pi button. Now, probably in middle school, because they didn't require you to buy a scientific calculator, they probably made you calculate it by hand, and they probably a lot of times told you use 3.14 for pi, because you probably may not have been using a calculator. However, for our purposes, we're either going to leave the pi symbol in the answer, or we're going to use the pi button. So again, unless the question specifies, leave it in terms of pi or use 314 for pi, then automatically just use your calculator and use the pi button. The next definition we need to look at is the arc length. An arc length is a portion of the circumference of a circle. You can use the measure of the arc, and this is what we were already working with in chapter 10, because it's measured in degrees. When we talk about the arc length, we're talking about a linear unit, like inches or feet or meters or centimeters. When I refer to the arc length, again, remember, it's part of the circumference. So if I think about a real life scenario, like a piece of pizza, the arc length is going to be, if I were to cut off the crust of the pizza and then get out a ruler and maybe straighten up that crust and then measure how long it is, that's the arc length. It's not in degrees, it's measured in inches or feet or meters. It's a linear unit. But what we're going to be using is the measure of the arc, which is what we saw in chapter 10. And remember, the measure of the arc in degrees is always the same as the measure of its central angle. Now, notice here, this is the formula. So it says in a circle, the ratio of the length of the given arc to the circumference is equal to the ratio of the measure of the arc to 360. Because the whole circle has 360 degrees, but we're only talking about part of the circle. Now, I'm going to sort of simplify what's written here because we're going to see 3 different variations of this formula. So again, we're going to memorize it as length of the arc, and it's either going to be the measure of the arc, and this is in degrees, always divided by the full circle, which is 360 degrees, and then we're going to multiply that by the circumference. You may be given the circumference as an already calculated number, or you might also ask to find the length of the arc. They'll give you the measure of the arc, divide it by 360, but maybe instead of them already calculating the circumference, they'll give you a radius. And then you'll have to multiply it by 2 and pi to get the circumference value. Or they may ask you to find the length of the arc, and again, give you the measure of the arc, divided by 360, and instead, maybe they'll give you a diameter this time. And then you would use this one. So again, they're all the same formula, but what's different is the variation of circumference, whether they already give it to you calculated, whether you're given a radius, or whether you're given a diameter. Be able to take these formulas and find any missing piece, whether it's the missing measure of the arc, whether it's a missing radius, whether it's a missing arc length. So be able to manipulate these formulas and solve for any part of it. C, the variable C here, this is representing circumference. The R here, this is radius, and the D is diameter. So here's our first example. Now, I'm going to do this and give you 3 different answers here. First, I'm going to be leaving it in terms of pi. Then I'm going to also calculate the answer using 3.14 for pi. And then I'm going to do it one more time, and I'm going to use my pi button. And again, anytime the question does not specify leave in terms of pi or use 314, you're automatically assuming you're using your calculator and you're using the pi button. So for this one, it says to find the circumference of the circle given the diameter of 5 inches. Now, it's going to be very important in this chapter that you label your answers with the correct units. I will be taking off points on the quizzes and the test if it is not labeled appropriately. So the 2 formulas for circumference, again, that you're memorizing, you're either memorizing it as pi times diameter, or, again, remember you could flip it and do diameter times pi. Or if you're given a radius, 2 times pi times the radius, or rearrange it and say, you know what? I can do it mentally. I'm going to multiply the radius by 2 first, and then put the pi symbol. These 2 right here are good if you're leaving it in terms of pi. So for example, when I do the first example 1a, left in terms of pi, the circumference, I'm using diameter pi. So the answer here is just 5 pi inches. Now, if I were using 3.14 for pi, I would do 5 times 3.14. And then if I round my answer in the homework tonight, some of the questions just read what place you're rounding to. A lot of them say hundreds place. So when I multiply 5 times 3.14 on my calculator, it's just going to give me 5.7. it terminates. And then using the pi button, I would hit 5 and then pi and then hit enter, or 5 times pi. Once I do this, I get 5.7079. It's going to keep going. Rounded to the hundreds place, 15.71. And again, these are inches. The next one isn't asking me to calculate the circumference. It gave it to us. It's asking us to find the radius. So because I'm asked to find the radius, I'm going to go ahead and I'm going to use this formula. Circumference is equal to 2 pi r. So I'm going to go ahead and fill in what is given to me. So they gave me the circumference. It's 17 pi. I'm going to rewrite the 2 pi r. My goal is to get r by itself because I'm solving for r. Notice the 2, the pi, and the r are all being multiplied. So to solve this, I need to use division. You could actually divide both sides by 2 pi at the same time, but let me just do it step by step. If I divide both sides by pi, notice the pi's cancel on both sides. And now I'm left with 17 is equal to 2r. Divide by 2. And r is equal to 17 over 2. I'm going to divide it, and I get 8.5, and these are feet. We're just going to use the circumference formula. Next one is asking us to find the diameter this time. So this time I'm going to use the other formula. Circumference is equal to pi times d, or d pi, either way. I'm going to replace what's given to me. They gave me the circumference. It's 16 feet. So I'm going to put 16 in place of the letter C. Rewrite my pi d. And now, left in terms of pi, all I need to do is divide both sides by pi. It cancels it from here. So left in terms of pi, the diameter is 16 over pi feet. However, if the instructions, like here, say use your calculator and round to the nearest hundreds place, you will do 16 divided by pi. Once you do this on your calculator, you're going to get 5.0929 rounded to the hundreds place, 5.09, and these are feet. Now we have an application, a word problem. It says a car tire has a diameter of 28 inches. Let me go ahead and draw a wheel here. It's just a circle. And it says it has a diameter of 28 inches. And it says, how many revolutions does the tire make when traveling 500 feet? And again, they're telling us to use our calculator. So we will be using the pi button, and then we're going to round our answer to the tenths place. Do not round mid-problem. Leave the long numbers on your calculator. Now, 1 revolution of the tire is going to be the circumference. So I need to calculate the circumference of this tire. So I'm going to use, since it's given to me as a diameter, I'm using the pi d formula. So I'm going to replace my d with 28. So the circumference left in terms of pi is 28 pi. And these are inches. Now, notice it wants to know how many revolutions when it travels 500 feet. I need to convert these to feet. I know that there are 12 inches in 1 foot. So I'm going to take this 28 pi inches, and I'm going to multiply it by 1 foot over 12 inches. Notice the inches cancel. And now all I have to do is divide 28 pi by 12, and I'm going to use my pi button. Once I do this, I'm going to find out that the circumference in feet now is going to be 7.3303828, and leave this long number on your calculator. This is now the circumference in feet. Now what I have to do is figure out how many revolutions it's going to take. So now I take that number and I'm going to take 500 and divide it by that circumference. And it says to round to the tenths place. So rounded, once I divide this, I get 68.209. It's going to keep going. So rounded to the tenths place, 68.2 revolutions. If it said to round to the nearest revolution, I would just say 68. So it's going to be very important that you pay attention to the units in the problem. You may have to do some conversion. You may have to remember your metric conversions. Know how many centimeters are in a meter, or how many meters are in a kilometer. So you're going to have to reach back to your middle school dimensional analysis. So in example 3, it wants us to find the indicated measure. So for the first one, it wants me to find the length of PQ. Now, on this one, I'm also going to use my calculator. I'm also going to use the pi button. So I'm going to actually give you the answers both ways. Again, make sure you're reading the questions carefully when you do the big ideas homework tonight. Some of them say, keep your answer in terms of pi, and then others ask you to just calculate it. If it doesn't specify, it's expecting you to use your pi button. Now remember, the formula for the length of the arc, we always take the length of the arc, and that's equal to the measure of the arc in degrees divided by 360. And then remember, you're either going to multiply it by c if they give you the circumference, or if they give you the radius, it'll be multiplied by 2 pi r. Or if they give you the diameter, you're going to multiply it by pi d. So this is what will change depending on your given. So for this first one, notice what was given to me is the diameter. And then they gave me the central angle. So I know the arc, the measure of this arc in degrees is 75 degrees. Remember from chapter 10 that when you have a central angle, the measure of its intercepted arc is the same. Now I'm going to go ahead and write down the formula I'm going to use. Length of the arc is equal to measure of the arc divided by 360 times pi d, because they gave me a diameter. So let me fill in. Now I'm going to leave it in terms of pi first, so you're going to need to simplify the fractions. And then I'm also going to calculate it using the pi button. So if I fill in, I'm finding the length of PQ. So the measurement of PQ's arc is going to be 75, and it's always divided by the whole circle, which is 360, and then I'm going to multiply it by pi d, which is 9. Left in terms of pi, I need to simplify. So this is length of PQ is equal to, and now I'm going to simplify. I can simplify the 9 and the 360, make that a 1, make this a 40. Then I can also reduce 75 over 40, because right now I'm at 75 over 40 pi. I now need to reduce 75 over 40. I can divide them both by 5. So I can reduce both of these and make the 75 a 15 and the 40 an 8. So left in terms of pi, the length of PQ is equal to 15 pi over 8, and these are yards. Now, using your pi button, you would do 15 times pi, or 15 pi, divided by 8. Using your calculator, we will get, so using your pi button, the length of PQ is equal to, rounded to the hundreds place, 15.89 yards. So again, if it says leave in terms of pi, that is your answer. If they don't specify, that means you're using your pi button. For the next one, they want us to find the length of the circumference. So for this one, I'm going to be using length of the arc is equal to measure of the arc divided by 360. And instead, I'm just going to put capital C here, which is going to be the circumference, which is what they're asking me to find. So let me fill in, or let me label in my picture what I've got. So up here, this 60 pi meters, this is the length of the arc. Notice it's a linear unit, it's meters. The 270, this is the measure of the arc because it's the central angle. So it's going to be the measure of the arc is also the measure of that central angle. So let's fill in these two numbers and solve for C. So the length of the arc is 60 pi. The measure of the arc is 270. I don't know the C. This is what I'm solving for. Now I'm going to leave this in terms of pi first, and then I'm also going to use my pi button. What I'm going to do here is, if I want to leave it in terms of pi, I'm going to simplify the zeros first. Whenever I have a zero on the top and the bottom, I always chop them off. Now what I can do is simplify 27 over 36. I can divide them both by 9. So then this is going to simplify to 60 pi is equal to 3/4 C. Now I have to get C by itself, so I need to divide by 3/4. Remember, whenever you divide fractions, it's the same thing as multiply by the reciprocal. So I'm going to multiply this, both sides, by 4 over 3. So this will simplify. These all become 1s. So now I have C all by itself. And over here, I can simplify the 3 and the 60. And now I'm going to multiply 4 times 20, and I get 80 pi. And this was in meters, so this is 80 pi meters is the circumference, left in terms of pi. If it says using your calculator, we're going to multiply 80 times pi. And if we round to the hundreds place, we will get 251.33 meters. So again, if it says leave it in terms of pi, the answer is 80 pi. If it says using your calculator, it will be 251.33 meters. All right, next one. Again, find the indicated measure. Use your calculator, round your answer to the tens place. So notice I don't have any pi on these are decimals. So this is why the instructions just say use your calculator. We're not leaving these in terms of pi. So let's go ahead and do the first one. They want us to find circumference again. So again, I'm going to be using length of the arc is equal to measure of the arc divided by 360 and then times by c. The 61.26, this is the length of the arc. This is the measure of the arc because it's the central angle and it also has the same as the measurement of the arc. So let's fill in our numbers. So we have 61.26 is equal to 270 over 360 times the circumference. Now, since they don't want us to leave it in terms of pi, technically we don't need to simplify this fraction. I could just go ahead here, multiply both sides by this reciprocal, and get 360 over 270, and then multiply this. So 360 times 61.26, and then divide it by 270. And this is going to give me rounded to the tenths. This one's different. So rounded to the tenths place, once I do this, I'm going to get C is equal to 81.68. So rounded to the tenths, 81.7 meters. Now, if you'd like to simplify your fractions, you could have also simplified this, 61.26. 270 over 360. You could have simplified 270 over 360 to 3/4. It actually simplifies to that. And then you could have multiplied by the reciprocal and then gotten the same answer. And it still would go back to this. So for the next one, to find the radius, again, I'm doing length of the arc is equal to measure of the arc divided by 360. But now the form of circumference that I'm going to use is 2 pi r because I need to find a radius. So now I'm going to fill in what's given to me. So notice they gave me the length of the arc. This is the length. And then the 150 is the measure of the arc. So let's fill it in. 10.5 is equal to 150 over 360 times 2 pi r. Now, I could actually also leave this one in terms of pi. I'll go ahead and do that. So what I'm going to do here is I'm going to simplify some stuff. I can reduce, I'm going to cut off the zeros. And then I could also reduce the fraction, 15 over 36. I can reduce this, divide them both by 3, and make it 5/12. So 10.5 is equal to 5 over 12 times 2 pi r still. I could also simplify the 2 and the 12 and make that a 1 and a 6. So now I have 10.5 is equal to 5/6 pi r. I need to get rid of the 5/6 pi. So if I divide both sides by pi, I now have 10.5 over pi equals 5/6 r. And now I'm going to multiply both sides by the reciprocal. This all simplifies. And now I'm just left with r equals, and then when I multiply this, I would get 12.6 over pi. So left in terms of pi, this would be your answer. However, rounded to the tenths place, we would get 40.0 or 4.0 after I divide. And these are all feet. So on the next slide, they're giving us the definition of a radian. And a radian is a unit of measure for angles. What you've been used to seeing is degrees when you measure an angle. Now we're going to learn that an angle can also be measured with radians. And in a circle with a radius of 1, the radian measure of the given central angle can be thought of as the length of the arc associated with the angle. So here, we're going to learn how to convert from degrees to radians and radians to degrees. Right now, my Algebra 2 honors class just took a test on this. You do a lot of trigonometry and you do a lot of angle measures in both degrees and radians. We first teach you how to do all the trig in degrees, then we do the exact same thing, and then we change the unit of measure to radians. So this will be something that you're going to learn again next year when you take Algebra 2 honors. So what you're going to do is when we want to convert the unit of measure from degrees to a radian measure, we are going to use the conversion ratio of pi divided by 180. So what we will do is we will take the degree measure that they give you and you times it by pi over 180. So for example, if I ask you to convert 10 degrees into radians, and you're going to do this in the homework, and you're leaving it in terms of pi. So you have to simplify the fraction. So I'm going to take 10. I'm going to multiply it by pi over 180. I can simplify this fraction, change this to a 1, and change this to an 18. So 10 degrees in radians is pi over 18 radians. Now, keep in mind, because this radian measure, technically, a full circle is 2 pi. And if you think of pi as about 3.14, 2 times 314 is about 6.28. So in a full circle, there's a little over 6 radians. This pi over 18, this 10 degrees, in radians as a decimal, if I were to divide this, it's going to be 0.17 radians as a decimal. So know that it's less than 1 radian. Everybody with me on that? So this is 10 degrees, so it's approximately, in decimals, less than 1 radian. It's about 0.17 radians. However, in the homework tonight, you're leaving it in terms of pi. Now let's do the conversion from a radian measure to a degree. When I want to convert from radians to degrees, I'm going to take that conversion ratio and flip it. So I would take the radian measure and I'm going to multiply it. Now instead of pi over 180, now it's 180 over pi. So for example, if I give you pi over 4 radians, and I ask you to convert that to degrees, I'm going to multiply it by 180 over pi. The pi's cancel, and then I'm going to simplify the 180 and the 4, just divide it. It goes in here 45 times, and then I end up with 45 degrees. This one, you don't have to worry about simplifying fractions. You're going to do the calculation on your calculator. So here, bottom line, the pi's are canceling, and then you're just doing 180 divided by 4, and it's 45. This is a common radian measure. You will see 45 degrees quite often because if you recall, we do special right triangles, and we're going to do special right triangles in radian measures. So instead of a 45, 45, 90, it's going to be pi over 4, pi over 4, pi over 2. So you're going to convert these into radian measures next year in Algebra 2 and work with the trig both in radians and in degrees. Now, if I were, and that's it on this one. So let's go ahead and do 2 examples and we're done with the notes. So it wants me to convert degrees to radians. So remember, we take the degree measure. We're going to multiply that by pi over 180. We're going to leave it in terms of pi for our homework tonight. So all we're really doing is simplifying this fraction. 15 goes into 180 evenly. It goes in there 12 times. And then change the 15 to a 1. So in terms of pi, pi over 12. So 15 degrees in radians is now pi over 12. And again, if they ask you to give the decimal form of it, you would hit the pi button and divide it by 12. But in the homework tonight, they do not want the decimal. They want it left in terms of pi. As a decimal, this would be 0.26 radians. Now let's convert the other way. Radians to degrees. I take the radian measure, 4 pi over 3, times this by the conversion ratio, which is 180 over pi. The pi's cancel. I can also simplify the 3 and the 180. Becomes a 1, becomes a 60. And now I multiply what remains. 4 times 60, and 4 pi over 3 is 240 degrees. Again, you could have done that continuous in your calculator. Just know the pi's cancel. 4 times 180 divide by 3.